Well, hey, everyone. Welcome to Howdy Partner. For those of you just joining for the first time, Howdy Partner is a show where we at AWS bring on some of our amazing partners to talk about the great work that they're doing. My name is Taz Miller. I'm a Partner Solutions Architect here at AWS, and I am joined from the AWS side by Michael. Michael, do you mind giving us a quick intro?
Hey all, my name is Michael. I'm also a Partner Solution Architect here at AWS.
Fantastic. And then from the CBTS side, Roger, do you mind introducing your team that you brought?
Yeah, by all means, and welcome everybody. Thank you for the opportunity. Taz, I can only assume from that introductory song that you're playing the guitar and Michael's on drums.
I only wish I was so talented.
That was good. That was good setup. Do you want to go to the intro slide there, and I'll just quickly.
Sure thing. Are you all sharing your screen already?
Sure. Let me make sure that I'm sharing here.
Cool.
And let me just pivot.
Yep.
Perfect. And let me get that up. Okay. Yep.
Yeah,
good to
awesome.
go.
So first of all, howdy. To stick to the brand of the show, I'm super excited to be here with our panelists. You know, I met Taz. I don't know, Taz, it was maybe a year ago,
Yeah.
and I was super impressed with the technical depth that Howdy Partner gets into, and so we really are bringing our senior technical engineers and architects onto the call. So I want to introduce Tim Salady, who's Senior Solution Architect. Tim, you want to say hi?
Hey, everyone. Thanks for having me on.
Yeah, appreciate it. David Gossett, who's a cloud architect as well.
Hey, excited to talk about some cool tech today.
Yeah, cool. Thanks, man. Scott Frankie. Scott, I'm not sure exactly what you do.
Yeah, I kind of help us out with everything AWS. I'm kind of our go-to at CBTS when it comes to anything AWS. Pro certified, all kinds of fun stuff there, but really just wanted to show you guys some fun stuff we've been working on and that maybe you guys can use too.
Yeah, awesome. And I'm Roger Hamshaw. I'm the product marketing manager that helps support the team from a messaging perspective. So we really want to keep our messaging from a presentation perspective to a minimum, but we do want to kind of set it up. If you're not familiar with who CBTS is, we're a North American data center, cloud, and managed services provider. And we really have, over the last couple of years, put our big bets on AWS. If you look over to the right, you'll see we're an advanced consulting partner. And if you look at some of the other certifications we have, specifically the well-architected framework, that puts us in a very elite status when it comes to the type of service providers that can deliver an end-to-end solution. So we're one of 258 AWS advanced consulting partners. That really the point that I wanted to make here was we continue to incentivize and attract talent that has experience with AWS to help our clients move to the cloud faster, and most importantly, in a secure manner. There we go. This is really just intended to show we offer, the first thing we do with the client is to understand your current environment. What does your current topology look like? What workloads are best suited for a public cloud? And understanding what is the most secure way to get you there. We do the design, the development, and the build of an AWS environment, leveraging the skill sets of everybody on this call and plus the bench of teams that we have in US, Canada, and India. We also do the heavy lifting, which is the migration. So we will migrate the workloads from either your current environment or from another cloud into AWS, and most importantly, we provide the ongoing management. So you really the model that we offer is a shared ownership model where we take accountability for the performance and availability of your AWS environment. So I'm excited to hand this over to Tim. And Tim, you want to take it away and kind of walk us through the rest?
Sure thing. Thanks, Roger.
You're welcome.
So we've been working on a project called the Data Lake Kickstarter to help you kind of understand what it is and give some context to like what we're going to show you. I'm going to walk you through just like a handful of slides. It's not a lot. I'm not a huge fan of slides anyhow, but just to give you a bit of background. So I've kind of presented this in more of a story format, and I'll just go through that. So once upon a time, relational databases were the solution to collect, store, and analyze data. Data sources and databases were really fragmented. You might have an API over here, you might have a MySQL database over there, a Postgres. And managing their schemas is a hassle. So if you need to add a new column to a database, typically it takes a lot of effort to really do that. You have to go through different teams and manage schemas, things like that. Managing and maintaining a large-scale database is also really quite expensive. You're talking about hundreds of millions, if not billions, of data points. You usually need very large databases to be able to handle that at any level of performance, and that's typically very expensive. Queries with large result sets are usually very slow. Even something like a T3 medium or something like that on RDS with just 2 million records may take like a minute and a half just to query it and pull that through like a MySQL dump. Building new ETL processes is typically really time consuming as well. So there's like no shortage of work to do when you're trying to build out really a way to store and query data. And so every day engineers would spend more and more time maintaining than innovating. So whether it's writing new scripts to existing processes or adding index to tables for every where clause condition, or you never need to export data, sometimes you need to create duplicate data, and you'll even spend sometimes weeks writing and verifying complex code. It's kind of a nightmare. Some on-prem databases like hundreds of tables, and they're really hard to maintain at times. So engineers would spend a lot of time maintaining and not so much time innovating. Until one day, AWS. So AWS introduced a flurry of different services that make building a data lake much easier than traditional processes. They're fast, scalable, relatively inexpensive, and secure, but building a data lake in AWS still takes time and experience. It requires a highly trained talent. How many people do you know are solutions architects who can build DevOps pipeline, maintain big data analytics, build out streaming systems, even go into databases and add index themselves? It typically have to wear many different hats, and that requires highly trained talent. So you can build data lakes and data services, but it requires experience. So because of this, we said, well, how can we make this process easier? Well, what if we built a prescribed, flexible, serverless, so that's kind of the keyword here, workflow, and make it really easy to deploy like simple infrastructure as code to an Amazon account, like 2 button clicks that solves a lot of common use cases for data lakes or data ingestion processes. And in the same breath, let's try to apply best practices around security and things like that. So we decided, why don't we build a managed service where we fix bugs, we add features to these different products is what we're calling them, but it would be deployed to your account. So unlike other competitors out there who have a user interface where you don't really have control of the underlying account or computer infrastructure, what if we just allowed you to deploy prescribed workflows, but also have full control over your AWS account as well? So you get the best of both worlds. And of course, it would be fully serverless, so really only pay for what you use. So we said, okay, well, that's great. We can create a prescribed workflow using infrastructure as code and automation, make it serverless. What's a use case we know that there is a gap in the market? So we started thinking, well, ServiceNow. So we built amongst many different things. One of these would be like, how do I download ServiceNow tables automatically and synchronize them at really any frequency interval? And how do I make sure that when they're coming in, that data, even if it has like 100 million data points from ServiceNow, how to make sure that it's data lake or big data like native format, something like Parquet. and how do I maintain a historic set of it, and how to make sure it's automatically updating its schemas and stuff like that. So one of the products we designed was this ServiceNow table downloader, and we have been testing it out, and you can download about 120 different ServiceNow tables fully, all the way back to the beginning of time, and maintain them for something like only $7 a day, which is pretty unheard of.
And ServiceNow is just the tip of the iceberg for us here, really. Internally, us being consultants, we work a lot with ServiceNow data on a day-to-day basis for tickets, dashboarding, all that kind of stuff. Our ServiceNow team doesn't always have all of the queryability that they want with the interface. Can't always really pull that historical data, especially, and kind of have like SLA dashboards, other things, live data running out of it. So that's one use case that we're using it for here. But really, just about any data set could go into the server lake or data lake.
Yeah, I think we're kind of, it might be jumping the gun. We'll talk about it later, but like we eat our own dog food with this stuff that we built for our customers. If you didn't catch on, we're talking about our own internal ServiceNow. Like our internal ServiceNow team loves this stuff, and as we're obviously not the only ones who use it. So.
Yeah, I would definitely touch more on that, but I'll just give you like a hint. A poorly optimized, even 80 gigabytes of RAM on-prem database for only 2 million incidents alone can sometimes take up to like 4 minutes just to do like a select all. Whereas you've got something like an Apache Parquet stored inside of Athena and Glue, it takes like 20 seconds.
Probably costs more than $7 a day too. I don't
Oh,
know
absolutely.
how much that database would cost.
Yeah, so I only have a couple more slides here, but basically that wasn't the only thing we'd identified that there was gaps in. We wanted to make sure that it was really easy to get started in building out a data lake environment, and we wanted to create prescribable workflows that where you can get something as simple as just go get me JSON data, or something as simple as I have JSON I need to push to the cloud. I want to be in big data native format, but I don't have to worry about any of the security or the roles or permissions or processes. I just want like, give me a tool I can simply push a JSON data payload to from an API. And so that's kind of like the path we started heading down.
You know what I really love about that is like, I know for me, like I love development work. And, you know, I love solving like the big problems. So the things that you just talked about, you know, the security, oftentimes we deal with tagging, all of like the very, very extremely important things that you need to do are often not that fun. So I love where you're going with this is you can take off some of that lift that is maybe not so fun, but extremely important.
And with going with the security in mind on that too, it also lets us kind of have some more fun with things with it. Yeah. So when we're looking at doing this in Athena and whatnot, and you're going to see through a lot of the slides that Tim's showing off here, in the data essentially is going to S3. That's realistically the back end for most of where the data is sitting. Well, if it's in S3, we can apply IAM policies to just about anything. We can limit who has access to what data. Since you're going to be querying it within Athena, we can even limit it even further to make sure you can't query data you're not supposed to have access to. And with these being prescribed workflows, we're trying to get out of the idea of it necessarily being a hard set product. And much more, we're not really trying to hide what we're doing. We're just trying to make an easy button to deploy these services. And then you can make your own hacks to it. You can make your own modifications and make it work for your situation a heck of a lot easier than starting from scratch.
Yeah, it's like I've managed to download 400 gigabytes of like ServiceNow data across 120 different tables. Okay, I can query it, but what if I want to do something special, like do like a cross join and produce an additional data set that I provide to my data analytics team, who's from a different data AWS account? That's all available to you. We're not restricting any of that. You still have full access to your AWS account, and you're not really seeing that with some other competitors as well. So we made sure we identify gaps of flexibility, usability, while still maintaining that price performance. This is pretty much it for the slides. Before I pivot into more of the technical stuff and less away from the boring. 4 bullet points is just kind of like what we're going to be looking at today. So the first thing is briefly touch on the user interface. So we know I mentioned that we built something. It's currently in progress, but it's a user interface that talks to a backend API where we can deploy some of these prescribed workflows on behalf of our customers, as well as even to our own accounts. And then we're going to dive a little bit deep into the product deployment automation, look at some of the technicals behind the scenes, maybe it's CloudFormation, the step function, some really cool stuff. And then finally, we'll take a look at that Athena and Parquet things. I'll have a chance to show you playing with that data and maybe get a feel for some of the cooler things we're doing behind the scenes, even with Glue.
Very cool.
And while you're getting the screens up over there, Tim, I did see a question in chat asking about CBTS. I think you hit on it, Roger. We are part of Cincinnati Bell, essentially. We started out as Cincinnati Bell Technology Solutions many years ago. As of, I think, about 2 or 3 years ago, we officially rebranded, and CBTS now stands for Consult, Build, Transform, Support. So it pretty well explains exactly what we do, and this is doing some fun transformation with data right here.
Now,
Absolutely.
I'm actually going to log into AWS's console in the background. So as we sort of go through these things, I can like show you what we're really doing behind the scenes.
Fantastic. Do you want me to throw your screen back up then?
Yep, that would be great.
Cool. Needed to minimize it for a second to make sure Scott's face could be bigger.
I've already got a big enough head as it is.
All right, are we good to go?
We're good to go.
Cool. All right, so the first thing here is a simple user interface. The kind of the way we designed it was we started off with just simple serverless infrastructure as code. Now we moved over to like building a backend API and then a front end interface. I'm going to kind of like show that in reverse order. I'm going to show a little bit of the user interface and then go more towards the technical stuff.
Cool.
So the first thing you're going to see here is this is a serverless React.js application. This is deployed to AWS S3. It's got a CloudFront sitting in front of it. We do use the serverless framework to go ahead and package it. It is produced through a code pipeline. So here I'll actually show you in the code pipeline itself. So let's take a look here. It's pretty straightforward stuff. We've hooked it up to a GitHub repository. So anytime we make a change, we do a code build to compile it. And then also we push it out to the environment and then do some post-deployment tests for verification. Once we're here, you can't do anything. So when we were designing our API, which I'll talk more about this GraphQL API, the idea was the Lambda should do nothing. When you go to access the user interface, there's no permissions at all until we go ahead and authorize it. So how we decide to authorize our requests is by using Cognito. We've used Cognito, and we use it in 2 different ways here. So the first one's going to be as a ADFS user. So we've hooked up Active Directory. So any users who are authorized can go ahead and do things by deploying products. And we also have functional users. So in case we've got automated users who still need access to the backend API or something like that, they can still do so. So you can see that Cognito URL up there. We do a nice SAML request, and we bring it back. And you can see up here, indeed, here is my username coming through Cognito, and here is a group and role assigned to my Cognito user.
Awesome. And so that could be as fine-grained as you would like.
Exactly.
It is. Because your Cognito user, by default, we have as permissions to do nothing. Only authorized users have the ability to do certain things. So in my case, I've got an IAM role. My IAM role has access to do like, let's be able to select certain DynamoDB entries or execute certain step functions, things like that. Yep.
And this is something as a customer I can define depending on what access I want. Is that correct?
So this user interface here is going to be the CBTS managed service super user administration. There's a separate user interface for just on the customer side. Today I'm going to go ahead and demo more on the managed service level user interface.
Cool.
But Michael, on the customer side, you are right there, though. It won't be, there's not going to be that many different levels per se, but you would at least have administrator and view only type, especially. So somebody can get in there and still see everything that's happened through the UI, that they don't actually want to hit the buttons or be afraid they could break something. Yeah, we can make sure that that doesn't happen.
Cool.
Yeah, we mentioned earlier that all this stuff is getting deployed into, the end user customer's own account. They have, Of course, they have full control over their own IAM. They can partition the stuff however they like. So
that's right. And I'll show you a little more about that here in just a second. So here I'll actually click on customers, and this is all the managed accounts that we actually manage. And indeed, these are not just fake entries. These are actual AWS accounts that we have onboarded that we manage services for. Now, some are, for testing purposes, but they are real accounts. Now, what's really happening behind the scenes here is when we load up this API, which I'll now show you a bit more at the back end here, this API is calling a list of customers. Now, these customers, it's not in a relational database. This is coming from DynamoDB. So we are doing a query out to DynamoDB for a lot of different data. Right off the bat. So you'll see there's some connections here. You've got SpaceX as test company and org new user 2, and here's SpaceX and org new user 2.
I was trying to keep this lightweight too. With it being React.js, the data sets are all being pulled from the GraphQL backend pretty much live every single time you go to a page load. But with the GraphQL, as Tim's about to show you, it really lets us be really extensible in what data we can really pull into that front end.
That's right. And so what I'm going to do here is I'm actually going to get a new auth token. This is all just test data for test accounts, so I'm not too worried about that. I'll go ahead and pass in this auth token here. So this is that functional user I was talking about. So you could do ADFS or a functional user. This is that flexibility Cognito offers us. So here I've listed a list of customers. I'll go ahead and hit submit so you can see it is indeed working in real time. The reason why we chose GraphQL is because instead of like a RESTful API, we don't want to overfetch data. And we also don't want to underfetch data. We also want to apply relationships to things where relationships don't exist. So how do I take DynamoDB entries, which inherently don't have any relations, as well as AWS CloudFormation stacks and maybe substacks and maybe step functions, bind them all into one and make you able to traverse a relationship in one query as you want it. And that's kind of what GraphQL offered us and why we sort of chose to use it. And I'll show you a little bit more about that. So for example, here I say, give me a list of all of our customers, and that's really what's happening here. But we can see here, I'm also listing a number of deployed products. Well, how are we getting that? If I type in here the word deployed products, I can actually say for every customer, go get all the customers from DynamoDB. And then for every one of those, go ahead and get every one of their deployed products. And here I can just sort of describe what I want and it will return it back to me. So now if I hit submit, it's going to give me exactly what I'm asking for. I'm not overfetching data, I'm not underfetching, and I can get just the information I need to keep my queries really quick. In traditional REST APIs, it may actually include this entirely. It may, if I just ask for a list of customers, it may include just all of this by default. So if I don't want to like stress my database unless I don't have to, in this case, DynamoDB scales pretty well, but I get to avoid that.
So Tim, just a quick question for you. If you go back to that tab, for those who are maybe newer to GraphQL and trying to figure out how to get started, what tool is this that you're using here on your screen right now?
This is a default tool called Graphql Playground that comes with most standard GraphQL frameworks. So GraphQL is really, you can use it, it's a simple framework or package or library in many common languages. We're using it with Golang. We chose Golang as our backend API. We love the performance, the intuition around it. But you can also use it with JavaScript or even Python, stuff like that. In this particular case, we're using something called GQL Gen by 99 Designs. They provide automated schema generation, automated API endpoint generation, and even the ability to expose a playground endpoint, which is a built-in, if you're used to Postman, it's like a built-in Postman for GraphQL, all really just wrapped into one.
Yeah, it's pretty slick.
Yep, I kind of love it. It's kind of hard to work with it in Postman because it is kind of a newer technology. More about this as well. So I will only spend just a little more talking about it. But if you do decide to use GraphQL Playground, it comes with the built-in API documentation.
Very cool.
So for example, yep. So for example, I can see every single endpoint in the entire API system, as well as every input it's expecting and every output I can potentially get and every one of its data types that I can expect to get back out of it. And that comes for free. Wow. It's for free. The only way to build GraphQL is basically by building a schema. So once we build a schema in GraphQL, it automatically generates the endpoints and automatically generates the API documentation and applies it here to the playground as well. So
yeah, I think you could definitely tell, like just looking at the raw return there. Like if you imagine what that would look like from a standard REST API, right? Like a get on customers /
no, it would be like 3 different calls. You would get customers first, then you would get products by customer, then you would get count of them, and
right, you'd have to iterate through those and then filter out the stuff you don't need in the return, or ask for specific attributes, and you could just skip all the way to the end with this.
Yeah, so it's like for every one of so every customer get every deployed product, and for every one of those, like maybe get the step function used to deploy that product, and for every one of those, maybe get its status.
Yeah.
So this is also some fun stuff that Tim's showing right now that's really not necessarily getting into so much that you'll see in the UI, but They've pulled into the back of our API right here the step function detail even. So you can see every single deployed product. We have built-in logging within it to pull straight from AWS. It's getting pushed into DynamoDB so it can get queried out easily. But every single thing that the UI is actually building, is actually doing, we can get out of the API as well here.
This is coming right from AWS's API. So the customer is coming from DynamoDB. The deployed products itself, its metadata is DynamoDB. But as soon as you ask for step function, it's actually reaching out to the managed service part of the account to get the status of an AWS step function itself. So yep, that's coming right from AWS. So GraphQL lets us take non-relational data and different resources and different external data sources and bind them all together to make this holistic view where you can get it all in one place. And this is just our backend to drive our administrative user interface. I'm going to pivot more into show more about the actual Data Lake product itself.
I'm just impressed that you can do all that without a single for loop. You know?
I mean, it's kind of the concept of the product in general. We're trying to
right?
simplify more difficult things and use the easy button solution for it.
Yeah. Now you're getting me really excited. So the cool thing about GraphQL is typically in a RESTful API, you would do a for loop. And in GraphQL, as soon as we get a list of customers, that's one API call, right? Because we're using like Golang as supports multi-threading, it actually breaks up for every one of those customers and in parallel execute multiple simultaneous API calls out to AWS to get its related data. So we are actually doing a multi-parallel compute in the background to get every one of these customers' different step functions details all at the same time instead of like doing a loop and then appending it to a response.
Right.
That comes for free with GraphQL on Golang. Not always the case with like Python. It is mostly the case with JavaScript if you do it right.
And thanks for the new hand signal, Tim. I've always had code blocks and chunks and stacking, but now I've got branching. So that's a new one for me. I like that one.
Yeah, I've never used that one.
Well, let's see.
What's
Now
the doing? Like, is that like?
I'm thinking in the like the idea of like an architecture diagram of like a step function. You start with a lambda, lambdas go out, and they fan out like a cube.
Parallel processing.
It is. So diving a bit deeper into a customer, we could see that here's like a list of products we deployed for them. And I kind of talked a bit about them a little bit earlier, some examples. One of these is called the Simple Data Integrator. Back in my PowerPoint here, this is one of them. It's my data exists in JSON format somewhere. I don't want to have to build the automation. I don't have to build like a cron job. I don't want an EC2. I don't want to have to manage any secrets. I don't want to have to build a Lambda. I don't have to create the S3 bucket or the policy or any of the IAM rules. Do it all for me. And that's kind of like what this product itself does. And I'll sort of walk you through what it looks like to deploy one of these. So I'll go ahead and click deploy, and we'll see what's currently available. Click on Simple Data Integrator. And here we've got some basic options and advanced options. So I will call this as 1, 2, 3. And I'll give it a bucket.
Gaming. How do you know what I name all of my stuff? You guessed my
So here's also the really fun stuff. I've seen Tim go through this too. Essentially, if anybody like really works with data a whole lot, he's basically building a curl request or a postman request as he's writing this out. But we've just gone on and integrated it into the UI again to try to simplify things and do that easy button approach.
It is exactly. That's exactly right. It's how do I remove needing a developer, a DevOps engineer, maybe even a DBA, maybe a big data solutions architect. How do I remove a lot of that friction? Like even from something as simple as just like go get me JSON data. Something as more complicated as like a multi-parallel workflow for getting ServiceNow tables is like another one. So it's just like how to building out these different automated ETLs for data pipelines.
How wild would it be if that bucket name was taken?
Yeah, it would be incredibly wild. So as we type this out, we do have some type of checker we've implemented to try and enhance the user experience. Not because I think we need it, but because I don't trust humans as much as I should. So
yeah, we are live on a Twitch stream. Somebody could have you tabbed away from that. I'm sure somebody went and sniped.
Somebody already took it.
You sniped it already. Gone.
Oh, yeah. All right, we'll add some more numbers. Okay. So here I've just grabbed like a simple mock API here. I'm going to go ahead and submit this. I could do a request body if I was doing like a post, and I could add some basic authorization on that. I can use it. I can choose a schedule too. How often do I want to get this data? So for the sake of this stream, I'll go ahead and do once every minute or something like that. I have no number onto here, just in case someone's real cheeky. I'll go ahead and hit save and submit. And what's happening here is I'll actually show the request coming in here. So it's simple multi-step wizard. It's running a workflow. It did submit a request to our backend API. So here's that GraphQL engine we talked about there a second ago. And here's those request parameters. So we sort of pass in everything about what we're looking for here. So here's the product. And here's the response we're sort of looking for. And I'll actually go to the administrative user interface to show you what's really happening behind the scenes. So we started a step function. That's really what happened. We submitted an API call from React.js to backend API. The backend API then submitted a step function request. So here I'll type in deploy. And I can see that we are trying to deploy a product to a customer account. And here it is running. So we can see it just started here a second ago. And here's what's going on. So let me just...
That's where the magic happens.
This is where, yeah, one of the magic happens, yep. So the first thing that happens behind the scenes is it first verifies that the input is indeed correct. Don't trust the React.js user administration. Anytime there's user input, you should never trust it. So even though we let React.js submit it to the backend API, and we do a pretty good job at doing typecasting and things like that, we do verify a number of things are still correct. Like even though we verified the bucket name on the front end was not used, we're going to do it again here on the back end deeper. So we
You want
verify
to make
all
sure
the
somebody like me doesn't go in and throw a curl request and not use the UI to it anyway.
Well, using architecture like this, we could use the React.js user front end, we could use the API, or we could just hit new execution.
Mm-hmm.
Right? If I wanted to do testing without ever affecting like the backend API, or if I want to introduce a new version of this workflow and do testing, I could just copy all of this and then rerun it and replay it essentially over and over until it works good. So we try to make that architecture really decoupled, but also quite fluid. So we verify the input's good. We check to make sure that stack doesn't exist already based off of that name. If it did, we try to update it. We create a change set. We wait for the change set to finish, and then we go ahead and execute it. Once it's all done, it ends up being successful. So we'll just wait here a second. We can also sort of monitor what's going on. So even though it says running workflow, we kind of hide the complexity behind the scenes. If I actually go to the organization here, I might be able to see it running. So here it is running actually.
How's 1, 2, 3?
Yeah. So I'll go into here, take a look, and we can see that the resources are still deploying. Now, if this was finished deploying, I would be able to see all the resources inside of it. So I'll look at a different one here. And the resources we can see inside of it are like, what are the entire stack and all the resources and all the parameters passed into it. We're not trying to hide this from you. We're trying to make sure you understand exactly what you're getting. So bucket policy, Lambda function, IAM role for the event bridge, the IAM role for the execution of the Lambda inside the step function, a log group, there's the actual event rule itself. Here's the different role, I think, related to the step function as well. And then here's the actual step function itself. And coming back here, we can see that it's all done. And it says it's all done as well. That's because we're getting this information live as it's sort of coming in through AWS's API. We'll see that this backend AWS step function is succeeded as well. It took like 3 minutes because deploying brand new S3 buckets takes a little bit of time.
Sure.
So that's
And
it.
we're trying to show it on a live stream, so of course it's got to take a little longer.
Yep. So that's pretty much it from the front end here. That would be a product through a simple user interface. Didn't have to create anything. The way this sort of works is we have these different products and we parameterize them. So I'll show you.
Just as a clarification for everybody too, when we're saying products, it's kind of like the simple data integrator. We have some other ones that we're planning as well and working on. Just didn't want to have too much data overload in this today, but it's prescribed workflows. So if we're doing things like copying excess data off of database tables, especially from RDS, or literally if you're like, I already have all my data in a clean format, I just want to push it into S3 and have these crawlers ready to put it up into a parquet format and read it, cool, we can do that. Here you go. It's already secure. Best practices, encryption, everything across the board ready to go.
That's right. But yeah, so each one of these different prescribed workflows are, actually just had that up a second ago. Really what they are behind the scenes they are CloudFormation templates. Some of these have like lambdas with them and stuff like that we end up compiling and deploying as a package, and we version it. But really, the core of it is going to be a CloudFormation template that we deploy to an account. And I'll show you from a customer's view what happens. So if I go into here, we saw what that step function was to deploy a product to a customer account. But let me show you what it looks like inside the customer account itself. So to do that, I'm going to go to our control account, and we do have a cross-account role that we can use to manage our customer services for them. And I will attempt to log into that to show that to you. So
While Tim's logging into that, we use CloudFormation as the backend on this. Again, trying to use everything native AWS as much as possible. CloudFormation templates just really flow into the step functions almost too easily for us. Internally, honestly, I really like Terraform. Some of the original code for like creating a new organization account and some of the other stuff I actually passed on to Tim in the form of Terraform, and it was converted into CloudFormation instead. But since we're trying to make sure that we are eating our own dog food as much as possible here, we wanted to stick with it in CloudFormation, so it fits in the AWS stack perfectly.
I have a quick question. Will customers be able to build their own workflows to integrate into their own environments? Is that something that they can jump in and do themselves?
Yeah. So the idea of this is, imagine you were a person who had full administrative access to your own AWS account, and you can do whatever you want. Right. So the only purpose of this Data Lake Kickstarter is just to make your life a lot easier, to remove a lot of complexity. But if you want to get in there and build anything you want, like as if you own the AWS account by yourself without any of this on top of it, that's exactly what it is. So you have administrative access to your AWS account, in addition to be able to use this layer on top to help simplify things, should you want to take maybe an easier route. In the same breath, it also means that as like, let's say this data is ingesting correctly and you like it, everything's good to go. If you want to build additional workflows on top of that, like let's say JSON data is there, you want to convert that not to parquet but to orc format, you could just have your developers build against that and things of that nature. Yep. So you've got full control, and there's really no restrictions.
So I think like one of the catchphrases you hear a lot is AWS aims to remove the undifferentiated heavy lifting of development and stuff. And I feel like what you all are doing is you're taking that a step further and taking away some of the undifferentiated heavy lifting of setting up the data lakes or any of the other products that you can deploy.
Definitely on that. And I mean, also with these that are being flown, so like the simple data integrator that was launched here, how we showed it's a basic, more or less a curl when it gets down to it. I mean, Tim showed you in the UI of it, even like we're already passing in, you can pass in OAuth tokens or simple auth methods and stuff. Say you have something completely off the wall or some special like HMAC 256 that you have to follow with that. We're just deploying the base of the step function for you. There's nothing keeping you from going in and hacking that up as much as you need to make it work in your way. It's almost like going and finding the script you want on Stack Overflow and then just making your little tweaks to it to make it work exactly the way you want. This is just a prescribed workflow more than anything.
That's right. So in the interest of time, I'm gonna pivot a bit and finish off the simple data integrator thing, and like maybe talk more about the Athena and Parquet related.
Yeah, I'm excited to hear more about that.
So like for example, even just this simple data integrator here, we try to be prescriptive in a way that we know is really valuable. So a common mistake would be not storing your data in S3 in a glue or Hive partition format. So just like taking a bucket and throwing the data right into the bucket as is not going to be an optimal
Not
structure.
optimal? Oh, darn.
No, it's not.
I won't let you take a look at any of the buckets I've set up.
Yeah, logical partitioning in here. So Tim set it up with like year, month, day, hour. I mean, this could be extended even further if you were doing, multiple pulls per minute. If you had this running per second, you could then take it even step further in.
Minute
And the
level
glue
or
crawlers could be able to find it to ridiculous depth.
Yeah, the
Yeah.
idea is just like to prevent the future pitfall, right? Like just
Yes.
doing it correctly the first you would have to go and fall in this pit, not doing it this way yourself, get pretty far down your development and be like, oh crap, we gotta go, and now we gotta go change all the code that looks at this and whatever, right? So starting you from the right place is the whole idea of this.
So even like a product like this, like even 2 days ago, we released an update where we changed the file name. And here you're going to see output because this particular customer is not subscribed to the latest version of the product in order to make sure that they are frozen on this for this demo. But we have a new version of this where it's the name of each output file is not just output underscore epoch time.json. It's actually like what's the step function execution ARN underscore like some other different properties underscore like epoch time, and they have like a very distinguished separators. And that's because we want to make sure data is easily findable, filterable, removable in the future. Yeah, it's how do I prevent future problems and make it easier for developers in the future where they don't have to work through a lot of these problems that we've seen other people have before. So that's a simple data integrator. I'm going to close out a few tabs here and talk more about an upcoming product that we are working on, and that is that ServiceNow table downloader. So to do that, I'm going to log into a different account.
And Tim's logging into a different account because as we've been in the admin UI side of it, now we're actually logging into the actual customer account that's had some of this deployed in it already.
Yep.
So they're actually consuming the service, and these are all have been launched via the UI as well.
That's right. So yeah, this particular product is deployed into this account because we're still doing test experimentation on before we want to make it available to other people. So that's why we're logging into this account instead. And this is the customer account. This is not the control account we saw there earlier. This is just like how we saw that simple data integrator S3 bucket with the TAS naming in it was a customer account. This is the kind of the exact same thing. So hopping right in. Well, what this ServiceNow table downloader really is, it's a step function. It starts here. This step function is executed on a schedule. That schedule is defined by the customer. So in this case here, we've got once every 30 minutes. We chose 30 minutes as a cost optimization. We can go as fast as like 2 minutes. We've done 5, 15, we've done 24 hours. We really like the way 30 minutes feels because we can get analysis of data every 30 minutes. And that's really configurable. What this looks like here, I'll actually look at the one that most recently executed while this call was going, this live stream. What we do first is we say, okay, go get a list of tables the customer is interested in. In this case, they have subscribed to 60 different tables. And they've got massive tables in here as well. It's not just like, go get me a list of users from ServiceNow. They've also got stuff like, get me every audit in the system ever made. And that's not 100,000, that's not 1 million, that's like tens of millions of records. So we say, okay, for every one of those tables, go ahead and ask ServiceNow whether it thinks there's any new records in the last 35 minutes. For each one of those, if it does have new records, go ahead and kick off another step function. And we do that because step functions has a limit. You can only have 25,000 events per step function execution. So we kind of have to thread those step functions down a little bit further in order to increase parallel compute without hitting AWS limitations for some of these things. So for every one of those tables, then when we say, okay, I want to break it up even further. I want to do a parallel compute. So for every one of those sub-step functions, we want to get only 500,000 records. So if a table has 5 million, we might execute this 10 different times using an offset of 500,000 every single time. Okay, so once we figure out how many records need to be executed, from there we say, okay, I want to execute a Lambda. Every one of those Lambdas is responsible for getting 500 records from ServiceNow. So effectively, we can download. I know it's like I'll give you an example. An incident table being 2 million records would then break up into like several different executions, which would then break up into each one of those to several like 1,000 different Lambda sub executions, and each one of those Lambdas get 500 records, and then store them into S3. So it's pretty nutty. The reason why
I don't know if you've how many people like have tried to work with big ServiceNow tables, like kind of the normal way, just like hitting their API with a big server. But yeah, it takes forever. Like it is a mess. And what was it that that our ServiceNow team was calling you whenever you managed to
A wizard.
use, yeah, it was
Wizard.
wizardry. Yeah, this is black magic to be able to pull stuff out of ServiceNow so quickly. We're talking about we could do it every couple minutes if you like, and that's like from ServiceNow. Like that's what you're saying.
Yeah. Yeah, so the reason why we built this particular one is because AWS's native and very cool and very new AppFlow service does support ServiceNow, but it can only get 100,000 records per flow run, and those records are only in JSON format. They're not in big data parquet format. So if you go to query them using something like Athena, it's gonna be a little bit more painful. And we've got a table, I think even just like one of our examples is 13 million records. That's if you started off using AppFlow, that's great, but you're probably going to hit a limitation of its usefulness for this particular use case. Whereas ours goes back all the way back to the beginning of time and gets every record, makes it available. So once that data is downloaded, I'll go ahead and show you in S3. We do use a prescribed format. So I'll see here that there is 2 different ServiceNow instances that we're currently downloading data from. One of them is what we call CSM, another one is the standard ServiceNow data. We've called it whatever the customer's configured it to be named while passing credentials. And here is every single table that we, once again, have used Hive partitioning format. I'll go ahead and hop into one of these tables that people usually find to be the most interesting, which is going to be incident. So hopping to incident, we store that data in 3 different file formats. One is the source. Always store the source, no matter what. Before you transform it, just store the source. And we don't use any prescribed schema at this point in time. We also store a flattened JSON version. So if your information is high relational coming out, or you've got nested JSON from that ServiceNow data, we go ahead and flatten that for you, convert it to strings, make it nice and easy to work with later. And we also have a flattened parquet. So AWS Glue jobs really transforms this JSON data to parquet, and that's what I'll show you here in a minute. As data is downloaded, it's downloaded in source and flattened JSON. And then we have, at the very end of these step functions, we have a job kickoff. So I'll show real quick. Just in one of these executions here.
And talking about the flattened JSON, how we can stack things out that way. In JSON, you can have multiple levels and have different pieces down. The whole idea to flatten it is to literally push it all back up to the top level, so you're not going to have to kind of strangely loop through the data. I mean, Taz, you're talking about having to do for loops to pull data and stuff earlier. Yeah. That's really what you have to do in a lot of JSON data to make sure that you actually get a cohesive row for every bit of information.
Yeah. So for every one of these ServiceNow databases that the customer defines with credentials, we actually spin up like a downloader. So they've got 2 downloaders going. They have a CSM instance or whatever, and a regular different ServiceNow production instance. They really all use like the same script, but they just run differently, and that's because we use bookmarking. Bookmarking lets us really only process new data that comes into the environment. So if we run this and there's only 10 incidents, it's only going to convert 10 incidents and be done. Helps keep costs incredibly low as opposed to loading it up every time and converting it. So if we see here's like the Glue job script. I'll briefly walk you through what's happening here. We can convert not just like one table at a time per job, but we can convert a bunch of tables. So that step function that checked every 15 minutes for new data in ServiceNow, it can handle all 60 tables. And this Glue job can handle all 60 tables as well. And this is where we actually have a for loop. But because of Glue, and we're using the brand new Glue 3.0, which actually is faster, we're able to do a for loop in here. And because it's so efficient, got a nice for loop going. So we say, okay, for every table that you list, go ahead and load up the Spark engine. And then for every one of those tables, go ahead and load up their bucket path. So there's the table name. There's the database, and then there's the table, and then there's that source data that we flattened. We do use in partition and group sizing to be about 20 megabytes. We want our parquet files not to be tiny little 50 kilobytes. We want to at least be 20 megabytes. We found a nice efficiency around that. We didn't want it to be a gigabyte because we wanted this glue job to complete very quickly. For pricing, we found that if we said we wanted these glue files to be not 20 megabytes, but instead be 500 megabytes each, there might be additional optimization on top of that we might get. But on the glue pricing, to run this frequently, it goes from 3 minutes down to just 1 minute with something as small as 20 megabytes. So for each one of those, go ahead and read it, and then write it back out as snappy parquet. Now, the best part about this, and I mean, to me, the best part is we don't manage the tables. We don't know about the tables at this point. All we know is we have a table name, but we don't know any of the columns, and we don't know any of the column type schema. What this glue job does is not only does it go and figure out in a glue table whether that table exists or not, but if it doesn't, it creates the table and figures out every single column in this data frame and updates that. So an example would be if I just like drop this incident table right here, it would recreate it for me and add every column as part of that process.
And that would happen every time that
yep,
that runs. So
every execution.
Yeah. So you're making me want to do something real quick. So here's that sys journal field right there. I've actually just dropped that sys journal field incremental table here.
Let's do it.
We're doing it live.
And it's gone. So now if I go over to that step function here, and let's say typically it would do all 60 tables. Here I can actually specify, if I have a custom parameter, I could say instead of doing all 60 tables for the last 30 minutes, do
just that individual table in this case.
Just this journal field. And we'll see what happens. So it's this journal field. It's good to go. It's worth noting that it can download and it can figure out of those 60 tables which has new data and finish downloading them, saving it as JSON, and start that parquet job in less than 20 seconds, 30 seconds.
Wow.
It's bonkers.
Yeah.
So here's that input. We gave it this journal field. Now it's figuring out what new data it needs. Let's see whether it actually came up with any new data here. Hopefully it did. Great, it did. Found those 334 records, and it went ahead and started off that parquet job. So we're going to come back here. We're going to see that parquet job is probably running. Great, it is running. We actually can go to this output here as well. I'll do two different outputs. I'll show you one from a different one, which you can see completed in less than a minute. Every time this glue job runs, it can take like 40, 50 tables, complete them in less like a minute for converting their source JSON to parquet. And then I'll show you what a query that parquet looks like in a second.
And so really, this is also kind of showing the power of having this as more of a prescribed workflow rather than necessarily, a completely boxed in solution. Being able to change that table on the fly like that if you need to really do something quick, being able to add tables into it, being able to really even like adjust that grouping size of where we have 20 megs right now, as Tim was saying, if 100 megs or 500 megs is better for your work use, do it. We're not going to stop you.
That's right. So here's a different output log. We can see that here's all those tables that it went ahead and did super quick. You're looking at just a few seconds for every table. It's reading into the data frame. And that's the best part about it is it's like only 3 workers. Wow. Because we're doing it incrementally with a bookmark, I don't need 20 workers. I don't need 100 workers. Maybe my first run, it takes a little bit longer. But after that, it's smooth sailing. So here we can see that that sysjournal field is running, and it completed in just shortly after. Now, the reason why this took so long is because it was creating the table. If the table already existed, we'd be no problem at all. If I come back to Athena, and that sysjournal field incremental is gone. I'll type that in here, sysjournal. We'll see it's not here, or not there. If I hit refresh here, there it is.
And there it is.
It recreated it. Yeah. And what it did was it actually figured out every one of those columns that need to be a part of it as well. And now I can go ahead and just query it to get my data out. So that's sort of the best part. Now I'll show you something even cooler, and this will, probably be, I don't know where we at with time, but.
Oh yeah, we got time. No problem.
Excellent.
We're about an hour in right now.
Yep. Excellent. So yeah, out of all these tables that's managed, the way we structure this is because we're getting records every 15 minutes, there are going to be duplicates in a good way. You want duplicates. And that is because, let's say I have an incident that comes in yesterday and today it's resolved. How do I know the history of that from a simple SQL query? I can't. If I maintained a simple parquet data set that always maintained a current snapshot, I would really only have one incident record. That would be what its most recent status is. But really what I want is something called a slowly changing dimension type 2 table, where I get the history of that record across all time. Every time it's updated, anytime something new comes across, I want it all available to me. And that's why we've sort of named this with the underscore incremental. It's a slowly changing dimension table. So here, I'll show you just an example of that. And this data set was recently recreated, so for our demo purposes today. So if I do like a select all here, limit 10, I could sort of see this data come in. But if I do a count from the source table, I'm going to get duplicate records. Now I'm expecting 1.7 million incidents, which is not too bad. But here I've got, and you notice here it only scans 0 data, and it's able to figure out its total count in
Less than a second.
Less than a second, because it's in parquet format. If this was JSON, it would have to scan and open every single file, read all the different line number counts on that, do an aggregate of that, and that may take up to 15, 20 different seconds. I've seen poorly optimized parquet files. If you have your glue dynamic frame writer, and if it's uses the default and you don't specify a grouping, it will write the file sizes out exactly the way it reads it. So if your native JSON is like 500 kilobytes, it'll write it back out as 500 kilobytes. Even if you use basic grouping, it's 1 megabyte. You'll have like sometimes hundreds of thousands of files. Really painful.
And also to add to that a little bit, you're also going to pay for it.
Exactly.
You're going to be paying for that huge scan too.
Yeah, and that's kind of the point of why we've optimized as much as we can, not just in using the Parquet format, but also in the Parquet converter and everywhere else that Tim and all of our devs have done so much optimization work. Every second that we save of time actually usage in the serverless stuff, it's less. It's going to take less time. Since everything is serverless that we're using here, you're really only paying for usage. So if we have shorter queries, you're going to pay less. If we have shorter execution times, you're going to pay less.
Yeah, so it's something as simple as like, we did some experiments, like what would it take time-wise, and what's the amount of data scanned, right? In Parquet, you've got maybe something as small as 39 megabytes, or even sometimes just a few megabytes, but in JSON, it may be 483 megabytes, and you've got a few thousand of those that start adding up cost-wise using Athena, as well as time. So here we got 1.18 million rows. That's including duplicates. We've utilized something really cool in Athena, specifically Presto, called window functions. And what window functions allows us to do is run a query that we could do something called partition by, and we give it the unique value that we want, order by, and the really the version, and the version is essentially going to be the timestamp, because every time it's updated, we get that updated timestamp, and therefore we meet that slowly changing dimension table requirement. So I could say, okay, for every record we have, figure out if there are any duplicates of those records, and for every one of those duplicates, figure out which one is the most recent one, and then give it a rank. That rank will be 1, 2, 3, and 4. Now, once we have that, bring that back as a sub query, and then rerun that through Presto again, and only get me the records that match only rank 1. So get me only the most recent version of that record. So we can always have a snapshot as it exists today, real time Parquet data set. So just running this query here, which I'll remove the view part of it off of it so we can kind of just see.
While he's doing that, I gotta say, I'm gonna have to study up to keep up with all these hand signals. Like we're getting pretty complicated.
So here, in order to scan like 1.18 million records in Parquet files, and load it into the big data engine that is beautifully Presto, having it distribute the parallelization, and then bring that back. in its full data set only takes 17 seconds. On-prem, to do that, it takes us 7 minutes. Even if I remove out some columns like big text fields, it's still like 2.5, 3 minutes to pull back something as like 1.2 million records because it's poorly optimized. The database administrators aren't, maybe they don't know what they're doing, or you've got some developers who made some mistakes. In Parquet, you could just add a new column, and I don't need to add a new index. I don't need to add a new column via SQL. I can just add a new column to my data set, and it automatically picks up on that. It automatically adds it to that table. It automatically makes it queryable here, and it's efficient to get. Like this took 93. Go ahead.
I was going to ask, do you happen to know kind of like the general specs of what you're comparing to there to on on-prem server? Like,
yep, 60 gigabytes of RAM. On-prem MS SQL server, where you've got an incident table that contains about maybe 3 gigabytes of storage, but really needs to scan about 33 gigabytes of index data using clustering and non-clustered indexes to do a simple select all from an incident of 1.18 million records. I think it's like either 8 or 16 CPUs as well, with 500 gigabytes of solid state.
Yeah, so I mean, you can either, I guess, maintain a big, like the old way is maintaining those type of beasts, and this is just an S3 for whatever, 5 cents or whatever it is. Like, this is how we're storing it. So it's crazy, the difference.
And I love Parquet too, because you really only pay for what you use. If I want everything, I can get it. But in this case, let's say I just want the incident number. What happens to my time? Remember, this is querying this same data set. This is still the same S3 files it's querying. If I go ahead and run this, is it going to be 17 seconds and 90 megabytes? Or is it going to be 4.5 seconds and 37 megabytes just for getting the incident number itself? So you really only pay for what you use. You get all the best, the prescribed version of this gets you all the best optimization we can really think of from initial get-go. And what's funny is this is 37 megabytes. Let's hop over to S3. What is it actually like over in S3? And here's the best part as well.
There are a lot of best parts of this.
Tim gets really excited. He likes best parts.
Best parts. We'll go to the Athena.
Gets me thinking, the best parts of the brownies are both the edges and the centers.
That's right. Actually,
All just depends on what you're in the mood for.
There it is. So here's the bucket that was generated. All the glue logs are also stored in this bucket as well. So as the scripts, every time we update the script as well, it is deployed to this bucket. And all the different Spark UI logs, continuous logging, things like that are all wrote to here as well. So you can kind of keep track of it all in one place instead of using Amazon's default path, which is good, but not great. So we take a look at this table here, and I'll go into table equals incident. Okay. Here's that 3 file formats. And we'll see if we've added some naming conventions here as well, just in case you need to build additional processes for ETLs and you want to use the same bucket. I don't just place the data, or we don't just place the data in right on top of the bucket. We try to nest it in such a way that you can put things around it as well if you need to, and it's not going to affect any ETL processes. So let's say I had load equals incremental. If I've had another one called load equals merge, or process equals merge, or just some other bucket folder I want to create here, you can use the same permissions that we've already prescribed, things like that. So here's those Parquet files. The glue generates them for us, thankfully, and there's only 103 because we've optimized for at least 20 megabyte files. If I do calculate total size on this, what does that look like? We go back here to Athena, right? We only queried for 37 megabytes. It completed in only 4 seconds, which is pretty fast, all things considered, because it's reading from flat file storage. But the actual data set is 1.4 gigabytes. And that's really where the magic happens. Parquet is I love it. It's like magic. It's got a built-in indexer because it knows where the values of every column of every row that you would have had in those files as well. So it can actually just skip files entirely or read only certain sections of files. So this file, let's say between bytes, 16.8 megabytes and 16.9 megabytes contains my incident number. It skips right to that, ignores the rest, because it read the header of the parquet file. It knows exactly where to find it, extracts that out, and you don't pay for the rest of it. You only pay for just the segments that it actually has to read because it's in efficient format. If this was the JSON one, it would charge you for all 1.4 gigabytes.
Yep.
Finally, we are.
So breaking that down to cost though, because the scan that you did was what, 40 megabytes? Is that what we saw?
Yeah, it was like 39 and some change.
So like 40 out of 1400 megabytes, right? I think is the way byte math conversion. Yeah. That's like 2%, right? Like you're scanning 2% of the whole thing.
Yeah, I mean, I think it's pretty easy to see why this is where everyone should be moving to, and a lot of people are coming and asking to do this, like with all their data, like for cost reasons, for speed reasons. It makes a lot of sense, and so this is why we're building this stuff. Is like, okay, you have JSON data. Let's get it into Parquet. Let's start working with it for real in the way that we work with it these days. So
yeah, so let's
easily for people.
That's right. Let's say I've got some data analysts, maybe some engineers or even a BA who wants to like hop in and sort of like run a query against the data set. They kind of know what they want, or they query an existing view. And let's say each one of those takes about 40 megabytes. Now this S3 is not even like as optimized as it could be. It just finds a nice medium. It's not partitioned based off of date and time, because really anything under, I'd say probably about 400 million records with about 200 to 300 columns probably doesn't need partitioning that much any deeper. But as you start looking across time and your data starts scaling out to the billions of records, you would want to partition against time. But this probably accomplishes that up to like several hundred million rows for just one table. Totally fine. So let's say you're able to scan that, and it takes about 40 megabytes to get what you want out, and you query it for about 1,000 times a day, which for the big data engine to pull that back is totally reasonable. It costs you $5 a month. Compare that to like a 60 gigabyte.
Even just go and throw in there right now.
The license.
Just go and throw in the 1,200 megabytes or the 1,400 megabytes that was as the base, and just so people can visualize the difference there, because this is literally 3% of what it would cost if it was not optimized data.
Yeah, that's right.
Go and type in the 1,400. I just want to see, because we're at 580 right there. So if it was actually 1,400 of the megabytes scanned, so the 1.4 gigs that it had scanned every single query.
Sure.
And yeah, massive difference.
Yep. And that's like even like a chunkier one as well. If they wanted to get, I think, duplicate data. So let's say I want to do like a select all, or let's do like a select, maybe just sysid from incident incremental. I'll use the autocomplete there. I'm actually quite curious. Oops, sysid value. It might still be 30 megabytes. Okay, 16 megabytes, 2.5 seconds. Yeah, so if you kind of like just know what you're looking for, you can get even more efficient than that as well. And some tables which are pretty even smaller than that, would like to do like sys user next one of them.
I don't think you're gonna have ID value in there.
No, I've got incremental. Yeah, some tables are even smaller than that as well. So.
And that's huge, because again, like you're only doing that, in this case 1 megabyte, whereas the other way would still require the full 1.4 gigs.
Right.
Yeah.
We're showing this as like manual queries right now, but imagine also then being able to take these queries, shoving them into QuickSight to make dashboards with these. Are you going to be scanning those full tables every single time, or is it just going to be using this very, very small partition and making that dashboard very efficient?
Yeah.
And usable, honestly, like if you have to wait a couple minutes after you like want to ask it a question, like that's impossible to get actual work done.
It is. The reason why we really like Athena and Glue, and why we kind of like want to build anytime we're downloading data, even with a simple data integrator, we're enhancing that particular prescribed workflow to also include an automatically generated Athena database, and as well as table using like a crawler. The reason why we really like this as well is because you get like a single pane of glass across your different data sources. Earlier when we described that story, circling back to it's like, where are the problems? A lot of times it's human resource time is very expensive, sometimes even more expensive than the cost of a simple database on-prem or maybe like a simple RDS in the cloud. Having multiple data sources, it's hard to pull them together, but Athena is that aggregated view. Creating automated workflows to get really complex data and having it automatically generated and updated and things like that. That's really what we want to get into with these different solutions we're building. We do want to implement Athena probably as much as possible and less away from the RDS.
Very cool.
I think that's kind of like the high level for that particular solution.
Sure. So then I have a question then. So like we've gone over some, pretty awesome stuff. As far as like if there's anybody here watching the stream and they want to learn more, like how do they engage with you all? What would that process look like?
They would engage us through reaching out through us. I mean, us being a large consultancy firm, we do have quite a few salespeople and whatnot that are pretty privy to what we're working on here. You'd probably end up talking to the three of us on the call here right now about this also if we were to showcase it off to you. Taz, I believe you already put up the link to our managed AWS cloud link on the CBTS website. That's probably the best place to reach us at. That will get specifically to our cloud sales groups and get it out to the people that really can kind of get you in touch with us the best.
Awesome. And for the people watching, who should be reaching out to you? Like, what does that look like? What does that customer look like? What problems should they be thinking about right now?
Right. To us, I mean, and this has such a wide range.
Sure.
This could be to a smaller or medium-sized business that might not have their full-time AWS devs, and they want somebody to be able to launch this prescribed workflow, and they only have to make their tweaks and simply use it. At the same time, Tim's showing you this on using this at a enterprise scale service now for us to be able to pull the data out and really be able to use the data more effectively. This can scale infinitely pretty much based off of AWS's resources. That was another design option of why we wanted to go towards doing serverless as much as possible.
Yeah.
So we don't really have to worry about scalability. The scalability and high availability is completely built in. Most anything at this point, it's really going to be just optimizing those partition sizes in the parquet files based on your workload.
Sure. We have someone in chat asking, are you all taking any interns? It sounds like they're interested in what you've got going on.
CBTS does have a internship program. Yeah, there we go. Actually, K-Dune Sensi. Thanks, Kevin. That's my boss up in there in chat. So contact him directly.
There you go.
So if we've got time, we can probably talk about some even more technical stuff as well behind the scenes about some of the difficult parts about building against DynamoDB that we sort of solved. Like how do we list and query information just specific to certain products or customers using a single table design and a DynamoDB that is fully serverless and it's not provisioned capacity, as well as a little bit about Amazon Cognito as well. So I guess we can kind of hop into that.
Yeah, let's do it.
So let me just pull this up here. So a little bit more about our backend process. Every time we go to create a product, we create a code pipeline for it. That code pipeline, as we deploy new versions of that product, we figure out what the current version is. We increment that version, and then we package that product back up, and we push it to S3. Some of the Lambda code that we deploy, it exists in the control account that the customer also has access to talk to as well. So for example, that simple data integrator, we might provide a Lambda code, but that Lambda has cross-account access that is whitelisted to reach into a different AWS account to execute or download the zip file that contains that Lambda code as well. So if we need to do like a hotfix or patch, we're able to do that for you as sort of the auto-managed process. In addition, you have access to any new versions that come through our system as well.
Maybe we should back up. I remember you mentioned it a bit earlier how we were on an earlier version of this, but the way that we're actually just taking our stuff that we've built, deploying it into your account, and as we iterate, make better versions, we're not pushing anything out to you. Like you can go and say, "Hey, give me the newer version of this product." But once we've deployed something in your account, it's just stuff in your account, right? So
yeah. That's right. As new versions are basically created, we subscribe you automatically for the ability to deploy against that version. Either you can select that product and its version, or we can select it for you. But essentially, your existing account is not touched. So if you're on version 1.1 and we release a new version 1.12 -RC5 or something like that, you're automatically updated onto that unless you want to be. You can either update it using the user interface, or we can update it for you. But in order to maintain the integrity and security of your account, we don't do that automatically, but we could. We also support the reverse of it. So if you decide that you do want automatic updates, we can automatically deploy those recent versions to your account. Or you can get a change freeze. So we're able to freeze a version of the product that basically says, do not allow this version to change at all. So that's in environments that are really particularly important. So you might have that particular freeze to a demo account that you use to showcase on Howdy Partner to make sure nobody breaks anything would be a good example.
And to build on top of that too, part of the reasoning also behind being able to do a freeze on a single one, with this being so extensible, if you're making your own kind of additions to some of the code and the step functions going on, there's nothing that would prevent you as a customer from launching the same service twice, just even under slightly different names. So, if you're running the simple data integrator, but you have to do something special for your authentication method and need to have that pushed in there, you don't necessarily have to update the entire stack. You could make a side one, migrate things over, change where your data is pointing to in the back end, and boom, you're done.
Yeah, I think it helped answer that question that you had about what types of businesses and customers could get use of this, and so if you're a smaller customer and you're just like, okay, I could just hit a button and suddenly the output of my widget making machine in JSON, I can pull up dashboards and see what's going on in my factory. That's awesome. And I don't do a whole lot in AWS. On the other hand, and so you would auto update that, right? You just want the best stuff. Mm-hmm. But if you are an enterprise and you're deving your own stuff against this, right? Like you're using this as step one in a process and then doing other things on your data lake, then you can freeze it and it's all in your account under your control until the end of time. So.
Yeah, one of the ways we kind of see it used right now is a customer would have two accounts. One would be their development, one would be their production, and then they would have the development be auto-updating with the latest versions, but the production one would use frozen versions and would get updated either by them or by us at request instead of automatically. So there are different use cases. We support both of those.
Fantastic.
So hopping more into this. So in order to maintain a list of different customers and maybe the deployed products, we don't house any sensitive data in our metadata about the different customer accounts as well as products. Nothing really sensitive, but we do house that metadata in DynamoDB. I talked about that a little bit earlier for the GraphQL API endpoint, where we go ahead and hit that, and then we list their products, things like that. It's coming from this DynamoDB single table design, and we took really to heart what Amazon showcased at reInvent about advanced design schemas and principles. And I'll hop more into here. So we can see that its capacity is on demand here. I don't specify the number of units. If I go into view items, we can kind of get an idea of what this schema looks like. So here we've got the partition key. It's not just a single partition key that says like ID1 or ID2, something you might see in our typical relational database. And we don't have multiple tables. It's all in one table. So we say our partition keys should always be relatively unique, but the sort key definitely unique. The combination of those two making a composite key.
Sure.
So if I want to get like a list of all customers, what I could do is I could sort of flip these keys by using a reverse index. Because typically in DynamoDB, you have to do a query that says, okay, give me, I have to know my partition key, but my sort key can be fuzzy. I can start it with something, or I can make sure to include something. But in this case, if I want to get like a list of all my customers, I either need to maintain a single record that lists all my customers, or do something really clever. And so what we've done here is we created a reverse index where the sort key is the partition key and the partition key is the sort key. And we actually query on that in reverse. So I could say, I can grab this metadata customer, flip that in reverse, do a filter that says, I want my partition key to equal to this, but make my sort key begin with customer hash. Run. And it's making me into a liar.
That's what happens when you try to do things live.
Yeah. Well, it do be like that though. But that's essentially what we do. Is we basically got two indexes. One is like, give me the details about a particular product. I know its name. I know its schema. We use a pound sign to delineate between the idea of like domains versus identifiers. And we try to stuff metadata inside of the sort key to make it really easy. So we'll do like a split on this one. And that split will contain multiple properties. So we might have like product deploy, hashtag the execution errand, now hashtag maybe a product version, things like that. Yeah, single tuple design, cool stuff. As you saw in the API, works great. If I could just remember exactly how we did it.
Already quite a bit. You've covered an hour and a half, so.
Yep. I think kind of the last thing I have really to talk about here is just a little bit more about Cognito. It's awesome. There's a lot of different authentication services out there, a lot of different authorization. The reason why we chose Cognito to allow authorization for the backend administrative API is because it really just integrates with IAM roles really nicely. Because all of our services are AWS native, we get all of the benefits of an IAM role, a fine-grained permission. Even a DynamoDB, you could specify specific policies that let you query only certain data across a certain partition and sort key prefixes and things like that to really like limit your data set. So things you might see like on-prem, which is like a particular user that can only query a particular database or these particular records, we kind of get that natively right in DynamoDB thanks to the fact that we're using Cognito and can apply appropriate IAM rules super easy without having to integrate a third-party service, which might be a little bit more complicated.
Yeah, that's awesome.
And there's the regular users here.
Yep.
And then, of course, there's the identity providers for our ADFS, which is in federated identities here, I think. Yep, we can see that coming from our ADFS.
Very cool. So that's something that someone who wanted to try to use this, they'd be able to integrate with their own internal systems and stuff like that to manage users and stuff.
I think so. Yeah, absolutely. You can, I think, onboard your Active Directory. You can even bring other service providers as well, using Google or Facebook, things like that. Cognito just made it super easy for us. Inside of our code, what we do is we actually do like a switch role. So like I mentioned earlier, the Lambda's got no permissions. And so as you authenticate, what we realize is we get your JWT token, we figure out what your different roles are, and we grab the most highly privileged role that you have in a priority stack. We then apply a switch role on that Lambda to get whatever role is associated with that particular group you're in that's at the highest priority. And then now that Lambda has whatever permissions only you are allowed to do. That keeps our backend API secure with defense in depth, which is a good thing to have.
Yeah, absolutely. Well, cool. Michael, do you mind just giving a quick recap for the folks about what we've gone over so far?
Yeah, of course. So we've gone over the brand. I'm not going to say brand new, but the kind of SaaS offering that CBTS has here. We've walked through the user interface that they're providing, the GraphQL backend APIs and the positive that we have there, how you can use it to deploy different workflows easily using CloudFormation, as well as the ServiceNow workflow that you have and how it's taking advantage of both Athena and Parquet to really reduce costs, reduce storage amounts, and to really make a seamless experience. So you have these one-click data pipelines that if you don't want to manage, you don't have to. But if you want to continue to build on top of them and add more and integrate with them, you can, because you're the one who owns it. So that's kind of what we've touched on today. Anybody else want to add on to any of those items?
I think you summed it up pretty nicely right there.
Yeah.
Yep.
No, I think that my favorite part has definitely been the kind of comparing and contrasting the JSON versus Parquet querying, and the fact that that's built in to what you're doing is that converter is pretty awesome.
Yeah, this comes from experience. This was not guessing over and over. We've worked on some projects where a customer was or had previously downloaded continuously Splunk. They were running a Splunk query, and they were downloading that data set to S3. And so they had something like 34 billion data points just for one query across, I think it was like 6 months. And they had housed, I think it was like 35 terabytes of data, and it was all in JSON. None of it Parquet, none of it big data. And they had
you to say that, like, it was all
well,
JSON.
we can only query like a certain amount of data at a time. I can't query across a large span of time because Athena times out. It's too much time. It's too much data. And so Athena doesn't make sense for not big data file formats, anything that exceeds tens of billions of rows in something in some like JSON. It's great for simple data sets, but if you start looking at getting really serious about big data and you want your data to be optimized, best practices are all around, and we try to apply it from that security IAM roles, deploying bucket policies, making sure all the security is enabled from the upfront, like public access is off, access logging is on, tagging,
encryption keys.
Yeah, encryption key. Everything's encrypted at rest. Everything, all the time. So, and that's obviously not on by default. Versioning, things like that. So, very prescriptive about best practices because I've seen a thing or two. I know somebody else probably wouldn't want to see a thing or two.
And the other thing I'd like to say also before we kind of wrap things up, like right now we showcased like the simple data integrator, especially, which is a data downloader. We talked about kind of like the simple S3 bucket methodology too, which is, hey, here's this bucket. You put the data in however you want, and it's still going to do the glue crawlers and everything else. But we have other products we're working with it as well. Some of you that are a little more keen-eyed may have seen RDS Copy in there. We are making a product that's going to let it hook up to just about any database you can really imagine. And the whole concept is are you really actually using that 2-3-year-old data that's sitting in the database, but you can't delete it because you got to run a query every now and again? No, get it out of there. Make your database smaller, make the database actually more efficient, but then still be able to use the backend and get Athena and query your data when you need it. And that's all pull methods, but there's also always the push methods as well. So Kinesis data streams can easily write the data for us and again, still go through all these same methodologies. But the whole point is really to get your data into a flat format in S3, hopefully Parquet. Parquet is really what we want to go for and really optimize, and then be able to query it within Athena. We don't want you to have to think about everything else with it. Just let your people run queries in Athena and call it a day.
Yeah, one of the things we do a lot of at CBTS are well-architected reviews. And I mean, Scott, we were in one like a couple of weeks ago, and it's just a common thread. Like, it turns out that EBS is a lot more expensive than S3, right? Like, don't store stuff in your always on active database. Like, databases are expensive. Like, that's kind of like been part of what we've been talking about here. And pulling stuff out of there and putting it in your like. It's almost like a database version of Glacier or something, right? Like that, right? It's like we'll come and we'll look at it if we need to, but it saves a lot of money, and like I said, it improves the performance of your database too, because it's not wasting all that space and resources on the stuff you're not really using.
Man, this conversation could get really fun. Like, because you're using an S3 based database system, you could even have lifecycle rules that transition your old data greater than a year to a smaller, less redundant storage in order to further increase costs as well.
Go to S3 and frequent access or something further back.
So the idea is like the cloud offers a lot of different flexibility, and some of these solutions aren't perfect for every scenario. But what we're trying to do is we're trying to say what are some common scenarios that there are typically a lot of pain, requires a lot of talent, a lot of time and effort, a lot of planning to really hop in there and innovate. That we've got to do so much work up front that it's really quite daunting. And how can we solve some of these right off the bat? So that's really what we're trying to target. The things we're working on now is still in development. It's currently in beta. As we sort of settle in, we'll polish the product off in the coming future.
Yeah, absolutely. So we do have a question in chat, and I'm wondering if you all do you all have experience using Kinesis data analytics at all? And would you be able to speak as to why you'd want to use Athena versus Kinesis data analytics?
So those solve two entirely different problems here. Athena is going to be the ability to query a large data set efficiently in parallel, whereas Kinesis Data Analytics helps me sort of analyze small streaming bits of data as it comes in real time. Athena is not a real-time engine. Rather, it's not supposed to be. Most queries take anywhere between like 1 second and sometimes even a minute, whereas something like Kinesis and Data Analytics, it's supposed to process data, maybe even transform it, or push it down to subsystem streams for further processing as it comes in. So kind of two different things. One's a real-time data stream process of analytics, and another one's just a query, a generic, abstract, efficient query engine, more on the big data side.
Yeah, but I mean, that being said, you could very easily imagine some type of system that's using Kinesis and like we offshoot some of it over to this system for longer term querying, right? Like you have your so that's where it's very easy to imagine doing both in the same incoming data stream, but one is going to be real time and one is going to be we've been talking here more about where it would land for longer term storage.
Yep. One of the concepts that we've actually have been talking about building does indeed use Kinesis, both data analytics as well as Firehose. So I need to have, I've got JSON and I need a place to push it. I don't want to have to build out an entire architecture, an API, create a Cognito user pool. I don't have to do all of that. I just want, give me a URL and give me a set of credentials that you automatically email to me. I have a script that pushes data JSON somewhere. Well, what happens behind the scenes to actually get it to its endpoint, and how do I analyze it on the fly? Literally, it's Kinesis, Firehose, and also data analytics. So that's one of those things that we're looking at as well. So you're kind of right on the money on that. It is something that people are looking for.
Very good. Cool. Well, I do want to give chat a last second. I think we're about to wrap up here. But please, if you all have any last-minute questions for the team, we'd love to hear them. But in the meantime, CBTS team, like, thank you so much for joining us today. I know that I was able to learn a ton from you all.
Absolutely. Thanks for having us. Had a blast doing this.
No,
Yeah.
loved it. If nothing else, we learned about parallel
Yeah.
computing.
Parallel computing. That's the new hand sign for it.
You know, the marketing guy on the call is going to run with that.
That's right.
More threads. More threads.
More
That's
threads.
right.
Great job, Tim and Scott and Davis.
Yeah,
Appreciate
absolutely.
the insights.
And so that kind of leaves us to what I think is probably the hardest decision that I'm going to make all day, which is how we're going to sign off this episode. And so we have a choice of 3 that I will give you all the power to choose our destiny. And so what we go through is we do either y'all come back now, you hear, giddy up, or happy trails. So
I think we'll go with the happy trails.
Oh, I was gonna say happy trails.
happy
We're in
trails.
agreement, yeah.
Okay, well then that sounds perfect. So on the count of 3, we will do our best attempt at saying a happy trails, followed by our sign off. But before we do that, I want to thank everyone who was able to attend the episode today. Please tune in next Wednesday as well. The Howdy Partner Show does run every Wednesday at the same time. And so, we're super excited to see you all next time. And hopefully we get to see CBTS up here again soon in the future as well. And so I guess with that, we'll go ahead and sign off. And so let's try it on the count of 3. 1, 2, 3.
Happy
Happy
trails.
trails.
Happy cloud trails.
Yeah.
Cloud Trail's never happy. All right, I'm leaving.